Do you know why I asked you to come here, Joe?
To get drunk?
Well, that goes without saying. But seriously, I need to talk to you about transition probability. It's very important.
So is getting drunk.
Remind me not to let you drive. Anyway, let's say you were in one state at a certain time and you wanted to know the probability of being in another state at a later time?
You mean like if the train from Delaware breaks down on the way to DC?
Not exactly. For one thing, DC isn't a state. What I had in mind was an example like this. There are two states, alive and dead. What is the probability that a man who is in the alive state at age 30 will be in the dead state at age 31?
12%.
It was a rhetorical question, Joe.
But how would we find the real answer?
Well, if we study 100 men aged 30, and 10 of them have died by the time they turn 31, the mortality rate is 0.1.
And that's a transition probability?
That's right, Joe, but it's not just life and death that can be states we transition between.
How about we transition back to the gold standard?
Go away, Ron Paul. Your political support is marginal at best. Anyway, we can also examine the probabilities of transitioning between healthy, sick, terminally ill and dead.
What's the probability of a dead 50-year-old being alive at the age of 51?
Well, obviously it's 0, since coming back to life is impossible.
What about the probability of someone who is healthy right now being healthy 1 month from now?
Well, it's the probability of staying healthy over that month, plus the probability of becoming sick, then healthy again before the month is over.
So the probability of being in the same state after a certain amount of time is always equal or greater than the probability of remaining in that state.
That's right, Joe.
And how would we know the probability of a 20-year-old still being alive at age 22?
That would be the 1-year survival rate of a 20-year-old times the 1-year survival rate of a 21-year-old.
What the hell does that mean?
Well, if a 20-year-old has a 95% chance of surviving to his 21st birthday, and a 21-year-old has a 90% chance of surviving to his 22nd birthday, the survival probability is 0.855.
I understand that because I can do the math in my head.
Good for you. Now let's destroy some of those brain cells with some booze.
What's the probability of us transitioning to a state of being totally hammered by the end of the night, Mr. President?
I'd say it's just about 100%, Joe.
Ha 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 ha.